We want to find the coefficient of z raised to the power L. So we're going to do this by using a binomial theorem. So our first example is the cube root of z plus the sixth root of z raised to the seventh power. And we're looking for the coefficient of z squared. So using the binomial theorem, we can rewrite this as the sum from n equals 0 to 7 of 7 choose n times a cube root of 7, a cube root of z raised to the 7 minus n times the sixth root of z raised to the nth power. And now we can bring this together. So the cube root of z, you can think of that as z to the 1/3 power, and then raise that to the 7 minus n, which becomes 7 minus n over 3. And the sixth root of z raised to the nth power is n over 6. So now, because they both have z as the base, we're going to add the exponents. So 7 minus n over 3 plus n over 6 is 14 minus n over 6. Now we're interested when this is equal to 2, when the exponent is equal to 2, because we want the coefficient of z squared. So we set 14 minus n over 6 equal to 2 and get that n is equal to 2. So in order to get the coefficient, we have to plug in n equals 2 into 7 choose n, and we get 21 as our final answer. Our next example, we have the fourth root of z to the fifth plus z to the negative 1 all raised to the 10th power. And we want to find the coefficient of z to the 8th. So using the binomial theorem, we can rewrite it like this. And the goal again is to get z under one term, or basically z to a power. But first we have the fourth root of z to the fifth, which we can write that as z to the 5/4 power. And then we're raising that to 10 minus n, which means we have to multiply that by 10 minus n. So we have 5 times 10 is 50, minus 5 times n is 5n, all over 4. And then z to the negative 1 to the nth power is just z to the negative n. Now we can combine these two to z to the 50 minus 9n over 4. Our goal is to set this equal to 8 because we want to find the coefficient of z to the 8th. Doing that, we solve and get n equals 2. So in order to get the coefficient, we plug it into 10 choose n. So we solve for 10 choose 2 as 45. Finally, we want to find the coefficient of z cubed for the square root of z plus the cube root of z plus the fifth root of z raised to the 10th power. So this one is tricky. So we need to have 3 of these, and it's going to be 10 and then n1, n2, n3. So this is no longer binomial. This is multinomial. And here n1 plus n2 plus n3 has to equal 10. And they're all going to be greater than or equal to 0, of course. So I'm just going to rewrite this. The square root of z raised to the n1 power is z to the n1 over 2. Cube root of z raised to the n2 power is z raised to the n2 over 3. And then the fifth root of z raised to the n3 power is z to the n3 over 5. Now I can combine the z, so we have z and then the exponent n1 over 2 plus n2 over 3 plus n3 over 5. So remember, we want to find the coefficient of z cubed, so we just want to set the exponent equal to 3. And now the only solution will be when each of these terms is equal to 1. So it's like, can we get this equal to 1? The answer is yes, because if n1 is 2, n2 is 3, n3 is 5, we add those up, we get 10, like we said over here. And then we just have 1 plus 1 plus 1 is 3. So that is the only solution. So we have 10 and then 2, 3, 5 like this. So it's 10 factorial over 2 factorial times 3 factorial times 5 factorial, which simplifies to 2,520. and that is a coefficient of z cubed.